Hi guys, sorry for the interruption. We have our first part of the discussion that we had already done on this. So this is going to be a continuation of the first part that we have already discussed concerning the graphing of two basic trigonometric functions. So therefore I'm going to have a continuation having discussed on the concept of a unit circle and the relationship that exists between this unit circle and the the two illustrations that I've already discussed on the board. Now we're going to see that the representation of this specific data in this graph is going to assist us to find some characteristic behaviors which we had mentioned, of course, which are basically going to be applicable or rather be seen in most of their applications. So therefore, I'm going to do a graphing of this, and as I said, this is just an approximation of the four values that I've indicated for the sine, the cosine of theta. So therefore, it's not an accurate figure, but an approximation which I've given to decimal places. So therefore, as I said, the concept of periodicity, whereby we're going to see that after a cycle of 360 degrees, the values for the sine and the cosine of theta are going to be therefore the same. And therefore, we say that the values or the graph or this particular feature for this kind of behavior, we call it periodicity. And therefore, we refer to the functions of the sine of x and the cosine of x as being periodic. So therefore, for the first value for the sine of theta, we're going to start with the first one, whereby we're going to represent the sine of theta for x is equals 0 degrees. We're going to get the value of 0 degrees, so therefore we can just have that plot. Now for the, sorry for that. For 0 degrees, I say this is the line for 0, the origin. So therefore we're going to have this value represented at this specific point. This is a negative unit and this is positive unit for our stretch for the negative and the positive part. So that is going to be, of course, understood. So at 45 degrees, we're going to have a positive 0.71. So having seen that this is 0.5, so therefore this is 0.75. So that is going to give us a value for around that particular point. Now for 90 degrees, this is going to give us a positive 1. So therefore it's going to be at this specific point. And then for 135 degrees, that is going to give us a positive 7.1. So I'm going to do a plot of this rest so that we can be able to see how it appears. Therefore, if you can try to look at the plot for the graph of the sine of x, where x has been represented by this stretch of angles, then we're going to have a graph appear as this one, whereby we're going to have the graph represented as such. Of course, this is a smooth line here. So therefore, we're going to see that there's going to be a full cycle from 0 degrees to 360, whereby the values of the sine of x are represented. So this is important because at any specific point along this graph for an angle, let's say 90 degrees, 93 degrees, for a good plot, we're going to see that we can be able to allocate the value for that specific trigonometric function given as such. So therefore, we're going to look also at the plot of the cosine of theta and try to see the difference between the two. So therefore, this first one is for the sine of x. Sorry for that. I've been using theta and x interchangeably, but of course this, for our case, is specifically x representing the angle. So this is a plot of y is equals the sine of x. Now next we're going to look at the second case, whereby we're going to have the cosine of x and try to see how that graph is going to behave. Now if you try to look at the values for the cosine of x, then therefore we're going to have a second plot starting from this specific point for the value of the cosine of x for 0, starting from 1, which is a unit though. So therefore it's going to appear like this, a continuation to this specific negative unit, and then therefore it's going to go like this. So this is going to be the value for a function of the cosine of x, And therefore, if we try to compare these two specific graphs, we're going to see that later in our discussion, we're going to compare the extent at which they are going to, stretch or rather deviate from one another. And this is going to be perhaps of a particular value which we are going to mention later. Now, in this case, of essence for us is to understand the behavior of these two different kinds of representations for the sine and the cosine of theta, as I've mentioned. So therefore, in our plot, or the other representations that we're going to do, perhaps in physical sciences, we're going to see that the sine and the cosine of theta can be represented just by a rough sketch. But basically, whenever we're required to use a graph, then therefore to find specific values, then we're going to be required to do a plot, as we have already mentioned in our previous part 1 of this specific video. So therefore, I hope that this is going to assist us in understanding how we're going to do different plots in case we come across them, and perhaps try to interpret some of the things that we have mentioned concerning perhaps the graph, the unit circle, and some of the values that we have seen being represented inside this specific table. And I hope that is going to play an important role for us. Now, catch us in our next video as we're going to discuss about the relationship that we have seen that exists between these trigonometric functions, especially concerning this. We said that in defining the concept of the tan of theta, which is another, an arbitrary angle theta, is another representation of a trigonometric function, which is a ratio actually between the sine and the cosine of theta. And we're going to see how it's the specific graph for the tan of theta behaves. And that is going to form for us in collaboration with this particular discussion, ways in which we can be able to interpret these graphs we come across them in any of our discussions. So that is it for today, guys. Bye. God bless you.